Hey guys, I just wanted to say before we start this video, I lost some of the intro and outro footage sadly. This video is going to be an overview of the RAAS system. That's Renin-angiotensin-aldosterone system. Additionally, I want to preface, I'm learning about these processes in my classes. However, I'm not a healthcare professional yet, so please do not take my word for fact. And just know if I say anything that's wrong, please comment it down below. I'm learning as you're learning as well. I just wanted to share the cool stuff that I learned. So yeah, I'm going to hand it off to past me. Thank you. Bye.
Even if I were hypothetically a healthcare professional telling you that this was true, you should always do your own research. That applies to many aspects of life. With that being said, I have my notes here. We're going to talk about the renin-angiotensin-aldosterone system, also known as RAAS. It's a signaling cascade of sorts that happens when the body detects that you have low blood pressure. Your organs aren't getting as much essential blood that it needs, so we need to make sure to fix that and fix that ASAP. That's what this is for. Here is the distal convoluted tubule, and depending on the size of the molecules within the blood or the polarity of the molecules, they'll either go into the proximal convoluted tubule or it will remain in the blood and go out through the efferent arteriole. We're here to talk about this. This area is the macula densa. Now you may be wondering, how does the body detect decreased blood pressure? The body detects it using these cells right here, your macula densa cells. Depending on the amount of sodium in the blood, let's say there's low sodium, macula densa cells are gonna signal to the body, we do not have sodium. Low sodium corresponds to low blood pressure. Step 2, the macula densa cells are going to tell granular cells, hey, that renin protein that you produced, we need you to secrete it ASAP, no rocket. Renin is going to be a very important molecule, protein, in this cascade. It's literally in the name. So it's going to kickstart a whole cascade of events that will eventually lead to us being able to increase our blood pressure. Now, step 3, renin is released from the kidneys. What type of cells make renin? 5, 4, 3, 2, 1. Granular cells make renin. A way that I remember this that I forgot to tell you guys, as long as you know that there are 2 types of cells in the juxtaglomerular apparatus. 1, macula densa, and 2 is granular cell. I just know granular ends in an R. It's the only one that has an R out of the 2. This is the one that secretes renin, and it makes it. Then macula densa tells granular cells to secrete them. So while granular cells make renin, it won't be secreted until macula densa cells recognize, hey, we don't have a lot of sodium. Renin leaves the kidneys, goes into the bloodstream. That's when it's going to find free-floating angiotensinogen. Angiotensinogen is not made in the kidneys, it's synthesized in the liver, and then it's deposited into the bloodstream. There's going to be an enzymatic reaction. You can just remember angiotensinogen. It's like angiotensin, except gen at the beginning, genesis in the beginning, you know. Then it makes this. I want to say it's an intermediate, but I'm not sure, so if that's wrong, I'm taking it out of the video. But angiotensinogen is bound by renin. Broken down, one of the byproducts is angiotensin 1. Then the ACE enzyme binds to angiotensin 1, then makes it and turns it into angiotensin 2. This is the active form that can be used to actively increase the blood pressure. And it'll do that through various mechanisms that we will talk about in the next episode. Just kidding. We're going to talk about it right now. Okay, I lied. We're not moving on to the next step because I left you guys off on step 3 and that was incomplete. So step 4, like I said, I kind of jumped the gun and went ahead of myself. With angiotensin 2, we can start various metabolic processes to increase the blood pressure of the blood. And we are going to go into some of those processes in this next section. Firstly, let's talk about vasoconstriction. Vaso, you can think like vasculature, vascular system. Then constriction, when you constrict something, dilation, when your eyes dilate, that's when they get wider. Constriction, when they get smaller. So vasoconstriction, in a nutshell, you're going from this to this. They have a thicker blood endothelium. If you think about it, blood would flow freely here compared to it flowing here. As blood flows in here, there's more restriction. So you're increasing the pressure, right? Increasing that restriction. Then, in addition, it's going to increase the glomerular filtration rate within the glomerulus. So that's just increasing the amount of urine that's being filtered through our kidneys. With that increased amount of filtrate flowing through, you're also increasing the amount of reabsorption that's happening. So you're increasing the amount of sodium ions and chloride ions that are coming back into the blood. With those ions, like I briefly mentioned before, water will follow. So as water follows, you're increasing the volume of the blood that's within here. And it kind of has the same effect here. Whereas while here we're increasing blood resistance, you're either trying to increase blood resistance or you're increasing blood volume to eventually increase blood pressure. Anyways, moving on. Next, angiotensin 2 prompts the adrenal glands to secrete aldosterone. The adrenal glands are sitting right above the kidneys. Aldosterone mainly functions by increasing the production of sodium channel pumps or sodium pumps. So it's making those sodium pumps, or it's making the cells make those sodium pumps, put them in the lumen. Sodium, naturally, it's going to want to exit the cell. We have a lot more sodium ions within the cell than we do outside of the cell. So following that high to low concentration, a lot of passive transport systems, sodium is going to want to leave the cell. As sodium leaves the cell, potassium is going to want to enter the cell, or they just flow in differing directions. Next, it's going to stimulate the secretion of antidiuretic hormone. Antidiuretic hormones increase reabsorption of water. They do this by prompting the cell to make aquaporins. You can think of them almost as like channel proteins similar to here, but they're for water. Aqua H2O. Porin, like hole, like a pore. And you may be asking, what cells are we talking about? We're talking about principal cells within the collecting duct of the kidneys. This whole process, it doesn't necessarily have a stop and start type of thing. I know a lot of things have like a positive reinforcement or negative reinforcement, something like that. This system, or from what I found online, doesn't seem to have that, but there are ways that you can combat this system. If you have any questions, please, like I said, comment them down below. Again, I'm not a healthcare professional, but I'm pretty sure I did my research. Catch you later. Peace.